Hi, and welcome to the next video in the number section, and in this video we are going to be looking at powers of 10 and specifically looking at multiplying and dividing by powers of 10. So, here we go, powers of 10. As we said in previous videos, our number system works on base 10, which means all the columns are 10 times more than the one next to it, which means the powers of 10 become a very, very important part of that. So, what do we mean by powers of 10? Well, you've got the number 10, obviously. And then you've got the next one, which is 100, which is 10 times 10, which I could write as 10 squared. Now, that 2 there, we say 10 squared, or we could say 10 to the power of 2, simply just means I've got two 10s being multiplied together. So that's 10 times 10, which is 10 to the power of 2. Times by 10 again, we get 1,000, 10 times 10 times 10, which is 10 to the power of 3 this time. And the next one from there would be 10,000, which would be 10 times 10 times 10 times 10. Which is 10 to the power of 4. And we could keep going and keep going and keep going. I'm not going to list them all, but I'm just going to chuck in that one, a billion, which is, now we're getting to a fairly sizable number here. You may or may not know how many zeros there are in a billion. So a billion is actually that number there. So it's a 1, and then we've got 3 zeros, another 3, another 3. So we've got 9 zeros altogether. And it's sometimes a good idea to separate the zeros out with commas, because it just helps keeping track of how many you've got. So that number there would be, oh here we go, 10 times 10 times, you can read that for yourselves. And as it turns out, we've actually got 9 of those all multiplied together, so a billion would be 10 to the power 9. Which, as I mentioned before, is a 1 and then 9 zeros, and it's kind of handy that we've got 9 zeros, it's 10 to the power 9, 9 tens all been multiplied together. So as soon as you see a number with a load of zeros, you know exactly how you can count the zeros, and that's going to give you a hint as to what's going to be happening next, which is what we'll see on the next slide. Now, you're not going to have to deal with numbers this kind of size. Chances are you're going to have to be able to deal with maybe multiplying and dividing by 10 or 100 or 1,000, but nothing a whole lot bigger than that. Certainly, I don't expect you'll get anything this kind of size, so do not worry if that size number is starting to worry a little bit. Right, on we go. Let's have a look at multiplying and dividing by these kinds of numbers. So, when you're multiplying and dividing by powers of 10, you can just simply think about the power of 10 as just causing the digits to move into a new column. And the number of digits you're going to move, or the number of columns you're going to move, is determined by the number of zeros. So we can see we've got an example here, 27 times by 100. So there you go, there's our columns all labelled, and there's the 27, 2 in the tens column and 7 in the units column. And we've got 2 zeros in 100, so that tells us that each digit has got to move 2 columns to the left. So, the 7 moves from the units column into the hundreds column, and then the 2 moves from the tens column into the thousands column like that. Now, if we just wrote it down like that, we'd still be writing down 27. What we've got to do is make sure that it's clear in the number we write down that the 2 is now in the thousands column, and the 7 is now in the hundreds column. So what we need to do is fill up the empty columns with zeros, and those zeros act as placeholders, so now it's very clear that that 2 is in that column. So 27 times by 100 is just 27, whack 2 zeros on the end, there you go, 2,700. Now let's have a little look at going the other way. So for example, if we're going to do a divide, say we've got 31 divided by 1,000. So again, there's our table with our columns, and there's 31 on it. And this time we're going to move our digits the other way because we're going to do division. The division is going to make the final answer smaller than what we are before, so this 3 is going to end up in a column that's going to be over here somewhere. It's going to be a smaller number, and as you can see already, we're going to have to move 3 places because we've got 3 zeros, and clearly we're going to need some more columns. So there go our extra columns. I've whacked in the decimal points because those are things you can imagine those things as just not moving there, seeing fixed, and these digits here are going to move past the decimal point and move into our new columns. So let's move them, and we decide we're going to move 3 places. So there goes the 1, moves 3 columns, that's now in the thousands. There goes the 3, there we go. And again, the same way, to make sure that this 3 is in that column, to make sure the 1 is in that column, we're going to need a placeholder to go in here. So there it is. And the last thing we do also is put a 0 in the units column, just to make it clear what's going on. So there we go, there's our final answer, 0.031. Now we said on the previous slide, the numbers got bigger because we're multiplying, and so the digits all move to the left. On this slide, we can see in this example, the answer got smaller because we're dividing, and we were dividing 31 by a big number, which is 1,000, and so we've got a small answer, so the digits all moved into columns to the right. And so the last thing, just to get you thinking, is have a bit of a think. What would happen, do you think, if we're multiplying or dividing with small powers of 10? For example, 0.01 or 0.01 or 0.000001. What would happen to the digits then? Which way would they move? And I'm just going to leave you to have a bit of a think about that one.